Really excited to be here today talking about how to build a end-to-end data analysis agent using Snowflake that not only queries your data and writes SQL, but also writes and executes Python code to help you get those visualizations and that more advanced analysis. So, quick introductions. My name's Hunter. I lead the AI Center of Excellence at Cboe. It's my picture. Here I am. Good to see you all. What are we going to do today? We're going to do a lot, but it's all going to make sense. I'm going to start off. I'm going to give you a little bit of background about what we do at Cboe, how we're using AI, and then the type of work that my team is focused on. That's going to be brief. Then we're going to jump into the actual interesting part, which is how do you build an agent that can analyze data effectively? We're going to start, and we're going to talk just in plain English about what we actually want this sort of AI tool to do. What are the core competencies that we need to get out of this agent? Then we're going to talk about what we need. What are the kind of core tech pieces that we need to build to make that happen? We'll talk about how to build or put together each one of those pieces, and then we'll build back up again. We'll take all of these pieces that we've talked through, we'll put them back together, orchestrate them, and talk about how to build this end-to-end data analysis agent. And then we'll tie everything together at the very end, and I'll give some general takeaways about some of the things we've found building and deploying AI agents at Cboe, and some thoughts on where the space is going. So, background. I promised I would be brief. You guys can hold me to it and yell at me if this takes longer than 5 minutes. What do we do at Cboe? Well, Cboe is a global exchange provider. We touch a lot of the assets that you encounter every day. Our most famous product is probably the VIX index, if you're familiar, the so-called Wall Street fear gauge. We also do about 20% of the US equities market. We operate the largest pan-European equities exchange, and we also operate equities exchanges in Asia Pacific. We also have a robust options franchise, futures, FX, digital assets, and a data arm as well. At Cboe, I lead our AI Center of Excellence. Really what we're doing there is two things. First off, we're building all of the technology that folks across Cboe are using every day to leverage AI. That's really that core set of tools that people need to work effectively in the AI-driven world that we're living in. Primarily, that's our AI platform. There's a couple of key pieces on this AI platform, but fundamentally what it is, it's a one-stop shop for everyone at Cboe to get access to the AI tools they need. And we're really meeting users where they are. We have a front end for our non-technical users. We provide an API and a Python package for our technical users to build on top of as well. That includes things like foundation model access, agents, tools, data sources and integrations, as well as data security and data privacy, so we can be sure that all of that kind of control work is centralized in one place. The other thing we're focused on is education. We can build all of the tech in the world. If nobody knows how to use it, then we will have wasted our time. So as well as developing this technical piece, we're focused on upskilling our associates, showing them how to use these tools effectively, and how to bring them into their day-to-day work. All right, I promised that would be fast. Hopefully I didn't disappoint anyone. Let's start by breaking it down. Let's take all these pieces that we want for our data analysis agent and figure out what we actually need. So, what do we want to do? Well, fundamentally what we want to do is we want to take a user query and we want our AI tool to be able to query data in Snowflake, understand what our data looks like, so be able to tell us things about where certain tables are stored, what different columns mean, that sort of thing. We also want it to be able to do more of that advanced analysis. So maybe it runs a simple regression. Maybe it's comparing multiple different data sets to extract insights. And then finally, we want to create charts and figures and all of these kind of supporting documents that you would expect an analyst to create. And then we want to put that all into a single result. So user asks a question, our AI agent goes out and it does all of these things kind of as needed, and it brings us back this kind of one result. That result can take a couple of different forms. You could just do your plain text traditional chatbot response with your charts and images interleaved. One of the things we provide at Cboe is an agent for building slide decks, for building PDF documents and Word documents. You could also put it into a format like that. And that's a key feature here, right, is these agents can work together within your stack to accomplish multiple different things. Okay, so we know what we want. What do we need to build in order to make that happen? Well, we need a couple of different things. The first thing we need is we need a way to access our underlying data. Duh, this one's obvious, right? We need a way to write SQL and get that data out of Snowflake or wherever it's stored. More importantly here, we need to understand what our data schema actually looks like. I'm sure many of you have tried asking an AI tool to write SQL, and it has probably failed unless you've showed it what your tables mean, what your columns look like, so on. Obviously, this is much easier now with semantic views, so really important piece here. Once we've written that SQL, we need to retrieve and store that data somewhere. Running the SQL is pretty easy. I think there's a whole menu of options that are available to run that and pull that data down. What's more important here is that we actually need to restore those results outside of the model context. Why is that? Well, let's say you have a user that pulls down 10 million rows of data. We have a lot of data at Cboe. It's not uncommon to pull down 10 million rows from a query. We can't feed that into the context window of an LLM. It's too big. And even if we could feed that into the context window, we probably wouldn't want to because it would cost us a lot of money, it'd be very slow, and it probably wouldn't work. So we need a way to store those results somewhere outside context, but still tell the model that they're around, and it can access them. The next thing we need to do is we need to analyze that stored data. So we need to give the model a way to execute and write Python code. And this needs to be in a safe environment, right? We don't just want our AI tool going into our server or our machine and executing random Python code, especially random Python code that's being generated by our end users who you may or may not have confidence in. And the last piece we want to do is we want to present all those results. So the charts, the images, modified data, cleaned data, all of those sorts of things need to be sent with the model response. But again, we have this challenge where we can't put them in context. So how do we get those pieces included? All right, so we know what we need to do. So now we're going to go through piece by piece, and we'll talk about how we can actually do each one of these things. And we're going to start easy here, right? Accessing our data and writing SQL is pretty easy with any modern language model. Just pick something. You can use Snowflake Cortex AI off the shelf and say, hey, write me some SQL to give me my top 5 customers in the past month, and it will do it. Well, there's a caveat here, right? It will do it if it understands what your data looks like. The real challenge with writing effective SQL is telling the model what your data schemas look like. What's in the tables, what's in the columns, what do they mean? Now, some of you might be blessed that you already have a production-grade functioning data dictionary, in which case, more power to you. I respect that. Some of you are probably like we are at Cboe. You have thousands of tables in your Snowflake instance. It would be time prohibitive to have an analyst go in and label every column and every table by hand. So how do we fix it? Well, just have a language model do it. Is it going to be perfect? No. Is it better than nothing? Yeah, probably. So in practice, you can just take a sample of your data, you feed it into an LLM, and you say, hey, this is a sample of my data. This is what the this is what the table is called. Write a description of what this table is what it might be used for, whatever. And that's going to give you that table level description. And then you repeat that exercise for each of the columns as well. And then very quickly you have a not perfect, but good enough data dictionary that will get you off the ground and running. The next question is like, okay, I have my data dictionary. How do I feed this into a language model? Well, again, if you don't have very many tables here, you're blessed. Just feed the entire set of tables into your model context and call it a day. If you have fewer than 100 tables, I would say this is the way to go. If you don't have fewer than 100 tables, you have this second problem, right? Which is like, okay, I have my data dictionary, but maybe I have 5,000 tables in there. I don't want to feed all 5,000 tables into my model context in one go. It's not going to work. It's going to be expensive. How can we fix that? Well, the good news is we have a solution for this exact problem, right? We can leverage RAG to effectively get the relevant tables in our data dictionary. And you can actually do this using a single SQL statement using Cortex AI. In practice, how does it work? Well, we take in this user query. We'll convert that into a numerical text embedding. We'll compare that to our embedded table level descriptions, and we'll get the top 10, the top 15, the top 25 most relevant tables to that user query. And then we can just pass those into the model context, and we're at the same place we would have been before. And again, you can do this all in one go with Snowflake Cortex AI in a single SQL statement. All right, so we've done a lot. Let's take a step back and talk about what we've actually done. So what we've done here is we've built a SQL agent. We've built an AI tool that can take a user query. It can understand what data is in our Snowflake instance. It can write effective SQL. How do you put it together? Well, there's two options here. The first option is your kind of tightly coupled, I don't want to say old-fashioned, but like old-fashioned workflow approach, where you take the user query and then you, by default, get the relevant entries from your data dictionary, you write the SQL, then you move on. Option two is what I would call our more agentic or loosely coupled tool-based approach. And I'm using a new word here, tool. I'm sure you've heard it a lot. What does it mean? Well, to me, an AI tool is just, all it is a function, right? It's a way to let the AI model call a function and do something external to it. Sounds simple, but why does this matter? Well, it matters because fundamentally, tools let LLMs and AI models do things that they're bad at. It's a translation layer between the text outputs from a model and advanced mathematical operations or any of these other things that a model is not traditionally tuned on. So you can use tools to translate from the language of text that the model is good at to some other language that the model might not be good at, and then back into text. Okay, so you take this tool approach and you divide up the two steps that we just laid out into separate tools. You have one tool that lets you search the data dictionary, where you say, hey, the input is a description of the table I want. The output is a list of actual tables in my dictionary that might be relevant. And then you have a second tool that lets your model write and execute SQL. And then the agent, what it's going to do is it's going to kind of call those as needed and leverage its own built-in intelligence to flexibly figure out what to do next. Okay, so we've solved the kind of data access challenge. We've figured out how to write good SQL. How do we actually retrieve the data? Pretty easy here, right? We all know how to run Snowflake queries. The harder part is how do we fix errors? Because our AI tool is not going to be right all the time. How do we make sure that when it writes bad SQL, we find a way to resolve that problem? Well, keep it simple here, right? Like, just return that error back into your language model and say, hey, agent, you just wrote this SQL, it's wrong, this is the error. Can you fix it for me? And it will go ahead and it'll fix it. And you can repeat that exercise, 2 or 3 or 5 times, whatever you feel is appropriate for your workflow before you eventually kill it. But you can kind of implement this self-correcting error handling. The other piece we want to do is we want to save the data, right? I said at the top that we don't want to feed everything into the model context. So we want to make sure that when we're running these queries, that we're saving the data somewhere. Again, I leave this up to your imagination. You can do it locally. You can do it in a Snowflake stage. Whole menu of options here. So now we have to store the data. Again, the challenge here is that our context is long. We don't want to feed everything into the language model, but we still need to let our agent know that the data is there and that it's somewhere. How do we do that? Well, to me, like the conceptual way of understanding this is that we want to provide a pointer to where that data lives and give that pointer to the model. That pointer could be a file name, it could be a location in a Snowflake stage, whatever. And then the model can say, hey, I know I have this data here at this location. And then down the road when we're writing Python or doing whatever, it can just reference that pointer rather than referencing those 10 million lines of data. Again, you can see at the bottom, you could store this locally as a CSV file. You could also store it in a Snowflake stage, just anywhere where you can indicate to the agent that it's stored. So let's zoom out again. Let's talk about what we've done so far. And the good news is we've come a long way. We've actually built a SQL agent that does this kind of end-to-end querying from Snowflake. We're taking in a user query, we're writing SQL, we're executing SQL, we're saving the data, and we are dynamically resolving errors. What are we still missing? Well, there's a couple things we're still missing. We need a way to access these stored files. We need a way to write and run the Python code that's so important to our analysis. And we need to do that safely, keyword safely. And the last thing we need to do is we need to return all of these files to our users. We don't just want text a lot of the time. We want to give these users these charts and these graphs. If our users are cleaning data or modifying data, we want to provide them the cleaned data. So we have to bridge that gap as well. Let's start with accessing files and sending the results. This is probably the easiest one to think through. And I think the best way to do this is to keep it simple. Decouple this idea of sending a file to the user and this idea of saving files. I talked earlier about having a pointer or a reference to a location where a file is stored. Really, we're just leveraging that same concept here to say, this is a pointer to my file, my model knows where it is, but it's not touching it. So how does that work in practice? Well, in practice, our SQL agent is saving a file, and we're passing that file location back into the agent. At the same time, we're providing our agent with this send file tool, where our agent can say, hey, I know the pointer to this file. Go ahead and send that to my end user. And the tool will just append that information to the conversation or put it wherever it needs to be put. The last thing we need, and arguably the most complicated, is how do we write and execute Python code effectively? As with the SQL, writing the code is actually the easy part here, right? You can plug in Cortex AI, tell a language model what you want it to do, tell it to write Python code to make it happen. As with the SQL, the hard part here is giving your model the context about what the underlying data look like, what sorts of analysis it can perform, what tools it has access to in Python, what libraries. That can be the more difficult part. I will say oftentimes the best way is just to give it a sample of the data along with that pointer, and it can start to understand what's in there. Or if you go more of the agentic approach, you can let your model do that kind of exploratory data analysis in Python and then feed those results iteratively back. The other thing we need to do is we need to have an isolated environment for running the code. We don't want user A to see the files that user B has created and vice versa. We don't want people using libraries they shouldn't have access to. And we don't want to end up in a case where one user is taking up all of our resources. There's kind of a menu of options here as far as isolating Python environments, all the way from everyone gets their own Docker image that you put in kind of a containerized workflow with dedicated resources, all the way to like, yeah, I'm just going to share everything. I'll leave it as an exercise to your imagination where it makes sense to fit that into your workflow. But there's a real menu of options here when it comes to giving that isolation and that multi-tenant environment. And the last thing we want to do here is we want to restrict the Python packages that our model has access to. I'm thinking here specifically about modules like requests, modules like OS that could be potentially problematic for an AI tool. And the reason it's important to restrict these, a couple of reasons. The first one is security, particularly if you have this tool exposed to users that are outside your organization. You have to assume they're going to try to do some interesting / malicious things. You want to make sure they can't do that. The other thing is just like the AI will get very creative with how it solves problems using Python. You want to be sure that it can't be too smart for its own good and cause problems for you down the line. Okay, so we've gotten through all of the individual pieces of what we need. Now let's take everything we've just talked about and let's put these pieces back together and talk about how to get to our true end-to-end data analysis agent. Again, we have two options here. We have the kind of structured, fully managed, user-defined process where A leads to B, leads to C every single time. We also have our unstructured / agentic process where we're letting the AI kind of control its own destiny and call things as it's needed. I will say here, I think the structured approach is most of the time not as good. The one use case where you would want to use this kind of structured flow, to me personally, is when you want to generate the same report every night that follows the same format, that uses the same data, that sort of thing. The unstructured approach is much better for all of these more open-ended questions that you're going to get from users every day. It also has some more benefits around scalability and maintainability that I'll touch on in a minute. But let's start with the structured. We'll talk about what this actually looks like. As you can see, somewhat complex here, but this is just everything we talked about already. So we're taking in that user query. We're using RAG to get the relevant pieces from our data dictionary. Once we have that, we're passing that as context into a new prompt, Cortex AI or your model of choice to write SQL. Once we have that SQL, we're going to run that, and then we'll either correct it if the SQL is wrong, we'll save it to our local machine or to a Snowflake stage if it's right. Then we move into the Python piece, and using those pointers that we saved off, we write Python using Cortex AI. We run that, again, either locally or in a Snowpark container. Finally, we just send all of the files that are in that user stage, as well as the model response to the end user. So there's a lot going on here. There's a lot of pieces that could break. Everything is very interconnected. If you change one piece in the middle, it's going to affect everything downstream of it. It's not a very robust system. But the upside here is that it's very, very deterministic. You know exactly what's going to happen every time, and you have a lot more control over what your AI tool is doing. Then there's the unstructured or agentic approach. This should look pretty familiar to that diagram I showed earlier. We have those same two tools. We have that tool that lets you find data and that tool that lets you run SQL and save off the results. All that we've added here is we've added a tool that lets it write and execute Python code, and we've added a tool that lets it send files when it's done. That's it. Now, I should take a step back here and say, like, one of the words that we've all been hearing this entire conference is agent. And I think it's important to like define what an agent actually is, because people say it all the time, and I'm not sure that people know why they're using the word. To me, like, all an agent is a system prompt and a set of tools. And then it's an AI, it's a language model, whatever, that is using that system prompt to give it instructions, and then calling those tools dynamically to give you the results you want. Nothing more, nothing less. Okay, which one of these approaches is best? I think, as you can see, I'm somewhat biased toward the agentic approach, but there's benefits to both, right? Starting with the tightly coupled, the real benefit here is, like I said, you get a lot of determinism, you get a lot of control over what's happening. This is excellent for processes where you don't want the model to like go off and cook up something crazy and then give you back a result that like doesn't fit the format you want or doesn't fit the schema you want. On the flip side, you have this loosely coupled or agentic approach. And there's a lot of benefits here, a couple of which I already touched on. So it's more flexible. It's less deterministic, which could be a pro, it could be a con. One of the big benefits here is that it's much simpler and more containerized. So you can make changes to one of your tools that an agent has access to without necessarily needing to change the entire thing. You can add and subtract tools kind of as you will to make sure your agent is doing exactly what you need it to do. That's a big difference from the structured approach where you can't really do that, right? It's very difficult to go in and change one thing without messing up your whole process. This is also better equipped for future models. Anthropic just put out Claude 4, 10 days ago? And Claude 4 is essentially optimized for this exact use case, where you have a bunch of tools, you have an agent, and it's running over the course of 5, 10, 15 minutes to give you back an answer. And last but not least, I think a really important one to call out with the agentic approach is you get error resolution for free. If you set up your tools in such a way that they not only return successful results, but also return any errors to the model, it will kind of self-correct for you, and you don't need to build these kind of complex rotary flows into your workflow. That's really huge. Makes it a lot simpler to manage this. So that's our SQL agent. We ran through that quickly, but let's just recap what we did, right? We took in a user query. We figured out we need these few things. We need to access the data. We need to execute the SQL effectively, save the files. We need to provide those file pointers to the model. Then we need to write Python code. Then we need to send back the results to the user. And then we have, as I just talked about, a whole menu of options for putting all of those pieces together to get the full workflow. So what does this mean for building agents more generally? How should we think about developing and bringing agents to our enterprises? Well, the first thing is that it's important to build trust. We have a lot of agents at Cboe that are doing a variety of different things. We have our data analysis agent that I just gave a high-level overview of. We have agents that are making files. We have agents that are doing searches, automating processes, a whole number of those common day-to-day business tasks. It's really important when you're trying to get people to use your agents that you do a couple of things. The first thing, obviously, is your agents have to work. It's oftentimes fun to experiment and build a really complex AI workflow, and 10% of the time, it does this crazy result that would have taken you 10 hours. That's great. If your tool only works 10% of the time, nobody's going to use it. The second thing you need is you need explainable outputs. Let's say you're doing data analysis and the model comes back and it says, I think our top 10 prospect customers are A, B, C, and D, but it doesn't tell you why, and it doesn't tell you how you got to that answer. No business user is going to trust that and run with it. And if they do trust that and run with it, you should probably be a little bit concerned. And the last thing you need is a pleasant user experience. I think the big one to call out here is streaming. When you're building applications, yeah, it's kind of a pain to deal with, but no user wants to sit and look at a loading wheel for 5 minutes while your agent is doing a bunch of stuff behind the scenes. They need to see what it's doing as it's doing it. They need to see the tools that it's running. They need to see the inputs. They need to see the outputs. And if you get those three pieces right, you get kind of this organic adoption of AI tools. You have one person on one team who starts using it, and they tell that to their friends, and their friends start using it. And you can spread this throughout your entire organization. What about AI agents? Where are these going? Well, I think the big theme here, and I'm sure many of you have encountered this at Summit, right? Agents are going to get increasingly autonomous. We're living in this world now where, maybe you have an agent and it will go out for 2 minutes or 3 minutes, and maybe it'll run 5 or 6 tools and it'll come back with a result. That's great, but I think the world that we're moving toward, and you've heard others talk about this, right, is you have an agent and that agent is going out behind the scenes and it's working for an hour, for 2 hours. And it's not doing some simple process. It's tackling very hard problems and then going end to end to find the solution. How is that happening? How are we going in that direction? Well, 2 things here. First one is faster, better, cheaper models. If you had said, 3 years ago, what AI agents today would be doing, I think most people would be pretty surprised. Not just because the models were not good enough to do it, but because it would have been incredibly cost prohibitive to feed in that many tokens. Nowadays, if you have an agent that's really doing valuable work, I don't think it's that unheard of to feed 500,000, 700,000, 1 million tokens in. If it's really working for an hour behind the scenes and delivering value, that's fine. The other piece is there's more availability of tools. You don't just have to create those on your own anymore. We have things like MCP that are really becoming more and more common and making tools available across the board. And again, like I said, model performance is going up all the time. Inference cost is going down all the time. I don't think anyone expects that trend to stop anytime soon. So, how do we stay prepared and build agents effectively? Well, to me, the first one is pretty clear. Let's build for our next gen models. I say this from experience. We had a version of our data analysis agent at Cboe that we built on top of Claude 2 using a kind of structured workflow, and it was pretty mid, right? Some of the time it would work, a lot of the time it wouldn't work. It took a long time. Nobody really understood what it was doing. And then Claude 3.5 comes out and it's like, oh shoot, now we can build agents and they can think for themselves and they can do things really effectively. If we had just started with that agent approach and acknowledged that there's new models coming out every 3 months, every 6 months, and built with that in mind, would have saved ourselves a lot of cycles. The other piece, and this segues, right? Don't build complex orchestration that nobody can understand, nobody can debug, and that breaks all the time. Instead, focus on building better tools that do things better. Let these models that are getting more intelligent all the time handle the orchestration for you. That flexibility that you get from leveraging the model intelligence is going to be 10 times more valuable than building every single edge case into your flow. And I guarantee you that your developers, or you if you're the developer, are going to have a much better time building that. The last thing, and Snowflake folks in the room, you'll like me for saying this, prioritize accuracy over cost. It's great if you build a tool and it's cheap to run, but if your tool is not accurate and it doesn't work and nobody likes to use it, guess what? They're not going to, and you will have defeated the purpose of what you're trying to do. So as you're building this stuff, build something that works first, and then once it works, figure out where you can strip out token usage, switch to more lightweight models, that sort of thing. Okay, so that was everything I have. We covered a lot in kind of a short amount of time, but I think that this should give you a really good framework for starting to think through how to deliver not just data analysis agents, but agents more broadly at your companies and start to build out these flows for your end users.